everyone, my name is Swarnima. I'm currently a sophomore majoring in biomedical engineering, and today I want to show you a really quick demo having to do with surface tension. It's really easy. You only need a bowl of water and a couple of paper clips, and please feel free to try this at home or pause the video at any time to see if you can answer some of my questions by yourself. So without further ado, let's get started. Alright, so I have all of my materials ready, and the first question I kind of want to start with is by asking you whether or not a paper clip will float on water. So let's try this. Feel free to pause the video at any time and think to yourself what is going to happen. So let me take this paper clip, let me drop it in. Oh, that fell. How about this other one? Let me see if this one will float. Oh, that fell again. But let's see if we can try to make this paper clip float in any way possible. So hopefully by now, after many trials, you have found that the paper clip actually is able to float. So why does this happen? We know that paper clips are made out of metal, so technically they should be more dense than water and they should normally sink. But here we're trying to ask ourselves why the paperclip is able to float. The answer has to do with surface tension. Hi again. So first let's talk about surface tension, especially in water. So if I can angle this correctly, hopefully you can see it without the glare from my light. Okay, perfect. So water, its fancy name, I guess you could call it, is dihydrogen monoxide, and H2O is the chemical formula of water. So water usually has this structure, O with two H's coming out of it. Now, water is made up of many of these H2O molecules. And these molecules are each attracted to one another through what we call hydrogen bonds. So these red dashed lines are what we call hydrogen bonds. And these hydrogen bonds in water are made with oxygen and hydrogen. The reason why water molecules are very attractive to one another is because of these strong hydrogen bonds. And this is essentially what surface tension is. It is the attraction of these molecules with one another at the surface of the water. And this essentially creates a barrier that allows the paperclip to float. Now, if you want to get a little fancier, do a little bit of a further experiment, one thing you could do is take a Q-tip and put some dish detergent on it, dip it in the water, and see what happens to the paperclip. So I have my dish detergent right here. Let me see what's going to happen. Alright, so I have a tad bit of dish detergent on my Q-tip. Let's see what happens. The paperclip sunk to the bottom. Now, why does this happen? So when we use the Q-tip with the dish soap and we put it into the water, we saw that the paperclip sunk. Why is this? So what the soap essentially did is it pretty much broke apart the water molecule so that that surface tension is not there anymore. That is why the paperclip sunk. So I hope you enjoyed today's demonstration. That is it. And hopefully at home you can try this with other liquids such as milk or even soda and see if you come up with the same results. Thank you so much again for joining me today, and I hope you guys enjoy the rest of Rutgers Day.